Narendran. So today's topic we're going to talk about basic pulse oximeter detection. So the first main board we talk about is the Arduino Uno RT, our main board that we're using. Second one is the LCD to view the SpO2 and the heart rate. So the third component is the Bluetooth Hex 606. So we're using this mobile to connect the Bluetooth. Then the sensor is the important part that we're using is the oximeter heart rate. So we have the field jump wire to do the connection and the USB Type B for the connect. So we show after this in the second part, do the connection between the Bluetooth, sensor and the LCD. For the LCD, for the serial clock line, we connect right here, and then the serial data for the blue wire, for the voltage rate, and then the final one, the black for the ground for this connection for the LCD. Okay, for the first one is the Bluetooth. So we connect, the first one is the voltage. So the second one is the ground. So the third one is the transit data. So the final one is the receive data for the RxD.
Good day all. Myself Navindraj Narasimhan, and as you can see, there are three types of wire fixed component then done by one of my roommate. So my thing is I'm gonna connect three of these into this Arduino Uno board. So without wasting the time, let's go to the installation progress. Let's start our installation progress. The first thing I'm gonna fix is the LCD. So as for the black wire, which is GND, will be going to the GND also. And as for the red one, which is our VCC, will be going to the 5 volt. Okay, 5 volt. As for the blue one, from SDA, will be going to the A4. A4. And as for the last one, SCL, is will be going to the A5. So this is from the LCD. So let's fix the Bluetooth. The first wire is the rate, which is from VCC, will be going to the 5 volt gain. 5 volt. And as for the black wire, will be going to GND. Okay. As for the green, which is TX, will be going to the 10. 1, 2, 3, 1, 2, 3, okay. Sorry. 10, okay. As for the orange, will be going to the 11, which is from RX. Okay. So this is our Bluetooth. As for the last one, which is the oximeter, so about the rate is from VCC and it will be going to the 5 volt. So I'm going to fix it there here, and later on we need to solder this wire because there's only a 2 5 volt hole in here, so I'm using 3, so we need to solder. As for the black one, will be going to the GND. Yeah, GND again. GND. And as for the yellow one, will be going to the A5. I'm going to fix it here. And as for the blue one, will be going to the A4. Sorry, it's keep coming out because we haven't done the soldering progress yet. As you can see, the pin are connected but not fixed under the main board. So as for now, this is the wall connection. This USB cable will be connected here. Later on, we can connect this to the laptop or computer to configure this device. So that's all for now.
Hi everyone, my name is Praveen Nair, and today I'm going to show you how to do soldering for pulse oximeter. And this is the jumper wire that is connected for VIN, GND, SCL and SDA. So now we're going to do soldering for the pulse oximeter sensor. Okay, now we already done soldering for pulse oximeter sensor. So next we want to solder another jumper wire to Arduino Uno board, so which is for 5 volt and then A4 and A5.
Okay, now we already done soldering for 5 volt, A4 and A5 pin.
Okay, since we already done everything for the installations and also the soldering part, so next we are going to do configurations setup to get output for heart rate and SpO2.
My name is Ranesh. So after the installation part, now we're going to do the configuration part. So after all installation on the Arduino motherboard, then I'm going to insert the motherboard to the laptop, which is using the Type D cable. So now I need to do coding inside the Arduino's software. So so now in the coding, actually it is previously we did this coding, but now we make a bit changes on this coding. So in the coding part, so we have the first line to the fourth line. What we did is include the necessary library. So the first library is the wire.h, which is the jumper wires. Second is the pulse oximeters library. Then the third one is LCD's library. And the fourth one is the software serials library, which is for the Bluetooth library. For the Bluetooth software. So the after line 6 until to the line 64, what we did is basic coding. Before this we learned on C+ programming, so we implement on this programming in this Arduino's programming. So for the Bluetooth, for the serial beginning is the normal beginning of the coding on any motherboard like Raspberry Pi, or we using Arduino, so that is the beginning. Even if you use Node MC also, we implement this coding too. So so the first line 21 to line 33, 36, it is the sensors coding. So when the sensor is detected, means the max 30100, which is our sensor's name, will be start. So if the sensor is not detected, so it will be showing the fail to initialize the max 30100 sensor. So it keep looping after that. So what we did is after that we in C programming will be print and train the program lah. So what we did is train the program on on the LCD, like the heart rate and BPM. And for the Bluetooth one, which is after you will see the output thing in the Bluetooth software, you will see the heart rate and the SpO2 lah. So that is what we did on the coding.
Okay, now we already done the configuration setup. So this is the LCD, oximeter and Bluetooth. And the next part, we want to do the testing, how it works. This is the pulse oximeter. So step 1, we have to place our finger on the sensor. So as you can see, the output from the LCD is heart rate and SpO2. So the heart rate must be 60 and above, and the SpO2 must be 94% above.
After reading the LCD, all the results, heart rate and the SpO2. So for this part, we're using the Bluetooth terminal. So we open the app, go to the setting, device. So this is the name of the Bluetooth. Press. So it is connected to the Bluetooth receiver, connected. So what my friend will place his finger in the sensor. So view the result. As you can see the result of the heart rate and the SpO2. So for all this result, we can share, we can save. To show you that, go to the setting, so go to the data, so you can share and save. For example, we want to share to someone like doctor, so for example go to the WhatsApp, then save it to someone, for example to your family, for your brothers or siblings. So this is the result. So we go back to the terminal, so we try to save. So series saved in the text form. Okay, that's it for the Bluetooth serial terminal.
Hi, good day everyone. Finally, we have done our basic pulse oximeter detection successfully. So, here we are to give a brief, get to knowledge thing regarding our real-time system project. So basically, as a leader, I would like to start from the base why we chose this title for our project. Mainly, our objectives are create and use pulse oximeter for detecting burst oxygen levels and pulse rates correctly. Secondly, design a clear display to show measurement data in easy process, which is you can see. Lastly, ensure the pulse oximeter is affordable and accessible for use at home and clinics. So now, I would like to ask Naveen, what is actually a pulse oximeter is?
Right. Thanks for asking me the question. So whether you're a healthcare professional, fitness enthusiast, or just curious about your own well-being, your own health, understanding how pulse oximetry works can be truly enlightening. So what exactly is a pulse oximeter? Well, it's a small device that measures the oxygen saturation level in your blood, and this metric often abbreviated as SpO2 and tells us how well our blood is carrying oxygen to the rest of our body. Now, why does this matter? Because oxygen is vital for our cells to function optimally. Monitoring oxygen levels can help detect early signs of respiratory issues, monitor the progress of certain medical conditions, and even optimize performance during physical activities. And there is a theory that if our oxygen level and blood cells are healthy and clean, humans could avoid 89% of the unknown diseases roaming around out there. So even though we have done it successfully, as my leader said, we do face a few difficulties throughout this whole designing, installing, implementation and configuration process, and let my member Ranesh express it how it actually felt and what we went through.
So I would like to share the difficulties that we faced through this process. So the first thing is, although we conduct survey about the hardware we prefer to buy it at the physical store nearby, because for my personal opinion, I won't trust online platform as the device could be malfunction. So the second measure is which is the Bluetooth module wiring issue, which we took around 2 days to settle it. So the third difficulties was the coding. So the coding part, especially on the sensors and the Bluetooth part, was a bit misconfigured. The coding should be in the line 4, but the error was in the line 4. But we make changes on the especially on the Bluetooth module. After that, it will be well ready lah. So after that, apart from those difficulties that I have mentioned, there is one or two precautionary steps to handle this device, and what are they?
Alright, thank you, Ramesh. So I'd like to talk about that. So firstly, make sure your finger is clean and free from any dirt. Secondly, try to keep your hand still during the measurement, as movement can affect the accuracy of the reading. Besides the precautionary steps, I also like to remind you about a few norms for pulse oximeter readings, which typically involves assessing oxygen levels and the pulse rate normally. So school-age children below 12 years old, pulse rate 70 until 110 beats per minute. Adults 12 until 18 years, pulse rate 16 to 100 beats per minute. Adults 18 plus, pulse rate 16 to 100 beats per minute. For knowledge, the oxygen saturation normally will be 95 to 100 for all ages gaps respectively. Keep in mind, these are the general range and individual variation may occur. So that's all, guys, and have a nice day. Okay, thank you.
So basically that's all from us. So the basic pulse oximeter detection system is finally done here. So that's all we can say, and is there any inquiries, feel free to ask us. So that's all from us from now. Thank you.